Bismillahirrahmanirrahim. Assalamu alaikum. Today we have second part of 16th lecture. First of all, we are going to the digraph or directed graph of the given relations. So here let's define these digraphs. A directed graph or a digraph consists of a set V of vertices together with a set E of ordered pairs of elements of V called edges or arcs. The vertex A is called the initial vertex of the edge AB and the vertex B is called the terminal vertex of this edge. We can use arrows to display graphs. ये क्योंकि रिलेशंस का जो पार्ट है उसके अंदर हमें ग्राफ्स में रिप्रेजेंटेशन ज़रूरी है, इसलिए मैं यहाँ पर आपको डायग्राफ्स के बारे में बता रही हूँ. अदरवाइज हम जो ग्राफ का एक पूरा चैप्टर है उसको हम एट द एंड ऑफ द कोर्स वो भी स्टडी करेंगे. जो रेलेवेंट पार्ट है उसको डिस्कस कर लेते हैं. Here we have a digraph with vertex set A, B, C, D and edge set as AB, AD, BB, BD, CA, CB and DB. This A, B, C and D, all the vertices are first drawn. Then this A to B, this part of the graph is known as edge. Similarly, if we draw a line from A to D, that is another edge that we can say in this you can say ये जो E edge set है उसके अंदर हम देख सकते हैं कि ये जो AD है, this is representing the edge between A and D. And this BB means that the edge is starting from B and ending at B. So here this is the edge which is known as loop. This is the edge BD which is starting from B and ending at D with some direction. CA means this edge, CB and DB. Right? Now come on this example. Let we have some set A 3, 4, 5, 6, 7, 8 and define a relation R on A as follows. For all xy belonging to the set A, x is related to y if and only if 2 divides x minus y. Draw the directed graph of this relation R. So if we see which elements are related in this set A, those are 3 is related with 3 because 3 minus 3 is 0 and 2 divides 0. क्यों डिवाइड कर रहा है 0 को? क्योंकि 0 can be represented as multiple of 2. Therefore 0 is divisible by 2. Thus there is a loop from 3 to itself. Similarly, there is a loop from 4 to itself, 5 to itself and so forth. Since the difference of each integer with itself is 0 and 2 divides 0. तो हर एलिमेंट को अपने साथ हम कह सकते हैं कि वो रिलेटेड है क्योंकि अपने साथ जब भी डिफरेंस लेंगे तो वो 0 आएगा और we can say that 2 divides 0 or 0 is divisible by 2. Note also that 3 is related with 5 because 3 minus 5 is minus 2 and minus 2 is a multiple of 2. Yes, so minus 2 is divisible by 2. And 5 is related with 3 also because 5 minus 3 is 2 and 2 is also a multiple of 2. Hence there is an arrow from 3 to 5 and also an arrow from 5 to 3. The other arrows in the directed graphs are obtained by similar reasoning. So by the reasoning we can see in the set A that 3 is related with itself, 4 is related with itself and all the elements are related with itself. Therefore there are loops on every element. Similarly, all those elements which are related with each other, so we have drawn arrows from 3 to 5 and then 5 to 3, 3 to 7 and then 7 to 3, 8 to 4 and then 4 to 8, and then 4 to 6, and then 6 to 4, 6 to 8, and then 8 to 6 and so on. ये सारे हमारे जो हैं ये डायरेक्टेड ग्राफ में सारे जो रिलेशन एलिमेंट्स के हैं वो इसमें. Right, now here we have some properties of relations. यहाँ 3 तरह की प्रॉपर्टीज हम डिस्कस करेंगे, जिनको वन बाय वन हम देख लेते हैं. फर्स्ट property is reflexive relation. So by definition, this is the relation R on the set A. This is called a reflexive. If A comma A belongs to R, for every element A belonging to A, यानी कोई एलिमेंट A अपने साथ उसका रिलेशन है, यानी A कॉमा A अगर रिलेशन में मौजूद है तो हम उसको कहते हैं कि वो रिफ्लेक्सिव रिलेशन है. आर द फॉलोइंग रिलेशंस ऑन 1 2 3 4 रिफ्लेक्सिव? One relation is 1 1 1 2 2 3 3 3 4 4, and the other one is also given to us, and this is the third one relation. So first relation R is not reflexive. Why? Because we can see in the set A there are 4 elements 1 2 3 4. So if this is a reflexive relation, then every element in the set A must be related with itself. For example, in this relation R, 1 1 is present, 3 3 is present, and 4 4 are present, but 2 2 is not present. So every element of the set A is not related with itself. अगर इसके अंदर 2 2 होता तो फिर ये reflexive relation था. Similarly, if we come on second relation, then we can see here 1 1 2 2 3 3 and 4 4. All the elements have its images. Therefore, this is a reflexive relation. Now, on third relation, we can see 1 1 2 2 and 3 3 are present, but 4 4 is not there. Therefore, this is not reflexive relation. Now, come on another property of relations, that is symmetry. A relation R on a set A is said to be a symmetric relation if BA belongs to R whenever AB belongs to R, for all AB belonging to the set A. Here in example we have a relation R 1 1 1 2 2 1 3 3 and 4 4. So here we can see that if we have some element 1 2, that is AB, then there is also an element BA present over here in the relation. Therefore, this is a relation. A relation is a transitive relation whenever AB belongs to R and BC belongs to R, then AC belongs to R, for ABC belongs to A. And let's take A as 1 2 3 4. And the relation R as 1 1 1 2 2 2 2 1 and 3 3. Is this a transitive relation? So here we can see that 1 2 is there, and with this element A B we can pick the element B C, for example 2 2. Then from these two elements we can generate element 1 comma 2 that is also present over here, already here. Then we can pick 1 1 with this 1 2 to make 1 2, that is also present. 2 2 with the element 2 1, that make the element 2 1, which is also present here. So this we can say that this relation is a transitive relation. Let's come on this next relation R that contains 1 3 3 2 and 2 1. So if we take any two elements, that is AB and BC, then we must have AC, that is 1 2, that is not present here. Or we can take any other element. For example, if we don't take 1 3 and 3 2, if we take 3 2 and 2 1, Then for these two elements we have A, B and B, C. So A, C must be there, that is 3, 1 must be there. That is also not present here. Or if we don't take this pair, if we take 2, 1 and 1, 3, that is A, B and B, C, then we must have 2, 3 here for these two elements, but 2, 3 is not present here. This is not a transitive relation. Here R contains 1, 2, 3, 4 elements in that have 2, 4, 4, 3, 2, 3 and 4, 1. This is also in a non-transitive relation, because you can see from here that if you take 2, 4 with 4, 3, then we have 2, 3 that is present here. But if we see 4, 1, no, 2, 4 and 4, 1. Okay. If we take this first and last element 2, 4 with 4, 1, then another element should be present, that is 2, 1 should be here, but it is not here. That is not the case. Therefore, this is not a transitive relation, right?